8 minutes have passed and now we have the clear winner. The clear winner is the program which does not throw any exception. It performed the best. So it's hard to ignore the exceptions in the thread dumps as well. Hello, everyone. If you are a software engineer, you would have already dealt with exceptions. In fact, a lot of exceptions. But are you using the exceptions in the right way? Or you are always throwing some unnecessary exceptions and that leads to the performance impact? So in this video, I'm going to share with example the performance, that is the compute time which it takes to run the code whenever you throw the exceptions, the debuggability impact, and also how do you write the correct code so that you can avoid the performance impact whenever you deal with exceptions. So let's quickly get started. Now I want you to have a closer look to this code. This is a main method, and here there's a function call which this main method does. And in this function call, it gets value from a hash map and returns the value. There is one catch that when the value is not present in the hash map, it returns internal error. So it is a way of communicating to the caller that this ID is not existing. So the contract says if the ID exists, return the ID, and if it doesn't exist, throw the internal error. So this is how the code is written here. We have a map, we have the main method, and there is a function call which is done. There is a class, a student class as well. It's a plain old Java object class. So let's have a look into it. Do you see any problem in this code? Well, many times people write the code of this nature, but there is one problem. The problem is that we are communicating the information using exceptions, whereas we could actually just prefer to return null, or there are other ways using which you could deal with the not found thing. But instead, you chose to return an exception and then you caught the exception. The problem with this approach is that it will have a lot of performance impact, especially when you are dealing with scale. So if I run this code multiple times in a for loop, I would see that the time it takes when the exception is thrown is much more compared to when exception is not thrown. So whenever you deal with the application which is highly scalable, a lot of throughput is needed. In those cases, it can have a lot of impact. Now, there is one problem in performance benchmarking using for loop is that it is not sophisticated and it will be undeterministic as well, because there is something called as JIT, Java just in time compiler. It will do some of the optimizations when the code is running. So it will not give you the right data. And on your bad day, this JIT will not work the way it is supposed to work. And you will have the memory errors and the server getting down. So this one actually does all the performance optimizations. To fix this, there is a tool which can help us in doing the performance benchmarking. The tool is called as JMH, or Java Microbench Harness. This is the GitHub link of the code, and it also has the step on how do you run this code. So basically, this is a standalone Java application you can run using Java minus jar and the code, and then you can import your project into this code and run it. There are IDE support as well, but they recommend running using command line. So what I have done is that while writing the code, I'm using the IDE, that is IntelliJ, but I will run the code using the terminal. So to run the code, we will do file, new project. And here we need to go to this Maven archetype. So they have already defined bunch of predefined projects you can run. Go to Maven Central, and here you search for JMH and then choose Java. I can give the perf benchmarking, and let's give com.anubhav, and then we can click on create. Let's create here itself. The project is built and you can run this project. So basically, there is a test method. You can write any test method here and you can run the code. For the purpose of this video, I have already written the code. So this class my benchmark, all you need to do is you need to annotate with fork, and you can give the number of processes you want to trigger. The warm up, that is, you want that whenever the loop runs, don't consider the first two iterations, that is iteration equal to 2. I want 10 iterations to be run within a process. I want to have the benchmarking by average time, and all the measurements will be in milliseconds. So don't worry, I'll put all these codes and the documentation in the description as well. So this is the class. There is no other class. You can see there is no other main class which is there. You just annotate a method with @benchmark. And this is a constant which I'm using to have longevity based run. So I have created a few methods. The first is measure without exception. So what I'm doing is I'm creating a for loop till 10,000. And what I'm doing is I'm just creating one after the other object. This black hole is an object given by the library. What it does is that it makes sure that the object is not garbage collected, so that the just-in-time compiler would not be able to optimize the code. Because in your bad day, JIT won't work and it might not be the deterministic solution. So we will be passing the objects to bh.consume. Likewise, there is another method that is here. What I have done is I'm throwing the exception. So I'm running bh.consume in the exception block so that the exception object is not garbage collector. This method and the third method both are same, but this one is using stack trace in throwable. Basically, the stack trace will not be generated in this case. Otherwise, the code is same as the previous one. And the last one is that I'm not doing anything here. So I still have a catch block, but essentially I'm not doing anything. So some people might have illusion that since I'm not doing e.stack trace, so I would be safe. So these 4 examples of running the code. One is without exception. The other is with exception. Third is with exception, but without stack trace. And the fourth is catching the exception, but not doing with anything with the exception. So this code is already there. What I'll do is I'll do mvn clean install, which will essentially build my Maven project. And then what I will do is java minus jar target and benchmark.jar. So I'll run this code. Now what it will do is it will run for around 8 minutes and then it will give me the performance benchmark. So let me pause the video and come back after 8 minutes. 8 minutes have passed and now we have the clear winner. The clear winner is the program which does not throw any exception. It performed the best. It performed with the speed of 0.024 milliseconds per process, whereas the other one where I was not having any stack trace. So when I was giving the JVM parameter of not throwing any stack trace, that was second. Whereas the other two, where I was dealing with all the exceptions, I was throwing the exception in try catch, be it I was having anything in my catch block, or the other case where I was not having anything in my catch block, they performed the worst. And you see the time got increased from 0.024 to 14 milliseconds. Such a vast gap between the two, the case where you are not throwing exception versus you are throwing exceptions. So clearly we have a winner here. Now you might say that Anubhav, I'm okay with the delay of 14 milliseconds. I don't have any problem with that. But now I would say that the next problem which arises for all of us, all the software engineers, is the debuggability part. Now, if you take the route of exceptions, the problem is that all your logs, all your thread dump will be cluttered with exceptions. And in many cases, whenever you go to the logs and you would see so many exceptions, and if you are a developer, you can tell that, hey, ignore these exceptions. These are nothing. But if there is somebody else, that person can get confused. Now you might choose not to log those exceptions, but even then, the thread dumps would still have the traces of it. So let me first comment this part and run the code again. So I'll do mvn clean install, and then let me run java minus jar target benchmark. Now this is running. Let me take the thread dump. Taking thread dump is fairly straightforward. You just first have to find out the Java process ID against which you need to take the thread dump. So JCMD. This gives us the process ID against which we need to take thread dump. In this case, it is 21799. And now what we need to run is JStack minus L. Give this process ID and then take PB copy. So it will take the thread temp into my clipboard. Now I will come back to my IDE IntelliJ, and here I'll go to code, analyze stack trace or thread dump, and let me paste my thread dump here. I'll do normalize and then click on OK. So you see my thread dump will contain this particular stack trace from this file, my benchmark line 88. Now imagine the nightmare which the engineer who would be looking into the issue will face. You might have coded, you might not have got the issue in the first place. Somebody else would be looking into this code. It will be a nightmare for them that they are seeing thread dump having this stack trace, and then later, after a day or so, when they meet you, you say, hey, ignore this exception, it's of no use. So it's hard to ignore the exceptions in the thread dumps as well. Back to the main code. So how do you communicate the errors to the caller function? One was using some exceptions. Example in this case, that the ID which was called is not there. So you threw exception, and here you can handle those exceptions. There is another way to deal with it, and that is not the good way. And a lot of people do that. In your code, you would have seen people returning null. But I will recommend against that, because the moment you return null, it raises chance of having null pointer exception in the caller code. So this is one of the ways to solve it, but I won't recommend it. There's another way to solve it is by having some variables. For example, you can have something like bool is success, and you can also have something like string error message. You can make it better by encapsulating and stuff. But now all you need to do is you can have one more thing called as Boolean success. And here you can do this dot is success equal to success, whatever. And now just make it true. And you can have one more constructor. That's another thing. And here, instead of throwing exception, you can have a return new student, some dummy ID. You can give -1, and the success is false. So in this way, you will not have a null pointer exception. So this is another way of dealing and making sure that you do not throw exceptions. There will be use cases where exceptions are absolutely needed. And in those cases, you can throw exceptions, but not for the code flow. Exception should be used only in the exceptional cases. Thanks everyone for watching this video. In this video, we have talked about exceptions in Java, which is the very common use case for all the developers. And here we have talked that you should not throw exception here and there, and you should be very sure about when you are throwing exception and when you can get away with exceptions, because having exceptions will generate stack traces. So having exceptions will not always be the good idea. We have seen the performance benchmark using the tools, and then we have also seen the impact on the debuggability as well. And in the end, we have also talked about how do you get away by having a object in which you can have something like is success and the error message. A lot of libraries do that. So in this way, you can save yourself from throwing exception, and still you can communicate the error messages and the details to the caller function. So that's all from my side. If you like this video, please like and comment. Till the next week. Bye.